Hey, sine function. We're going to be looking at the graph of the sine function today. Let's do a little review. I think this was 13.1. Could have been 13.2. I don't remember. So we have our x-axis. We have our y-axis. We have let's find the cycle. So a cycle will go from here to here. And let's see, how do we find the amplitude? That's right, it's 1/2 the max minus min. And how do we find the period? That's right, it's not the period, the midline. Midline's the average. Y equals 1/2 max plus min. Okay, the period. I'm just gonna, if we have a graph, the way we found the period is we just counted how many units the cycle was. In this case, 1, 2, 3, 4. The period equal 4. Okay, let's find the amplitude. Let's see, we need the max and the min. So here's my min. Here's my max. See, the max is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The min is going to be -1, -2, -3, -4. So the amplitude is going to equal 1/2 the max, which is 10, minus the min, which is -4. So 1/2 of 14 is 7. The midline is going to be 1/2 of the max, which is 10, plus the min, which is -4. So 1/2 of 10 plus -4 is 6, so 1/2 of 6 is 3. So the equation of the midline, the horizontal line, at y equals 3. Okay, so there's my midline. Remember this? Remember, this was all review. Fantastic. Okay. The actual sine function. Y equals sine of theta is the parent function. Okay. We're going to look at some transformations of this parent function. Just like we've been doing transformations. Do not throw things in my room, you childlike person. Just like we've been doing transformations all year long, we're going to be doing transformations on the sine function. Now, there is a coefficient in front of the sine. We'll call it A. There is kind of a coefficient in front of theta, which we'll call B. Okay. The A represents the amplitude, and the B is going to be used for the period. Now, this is the parent function here. It's represented on this graph. Starts at 0, hits its max, which is 1, goes through 0 again at pi, then it hits its minimum at 2 pi over 3, and then hits its end of the cycle at 2 pi. Children, stop. Okay, so the distance from the midline in our parent function, it actually is the x-axis, to the highest peak or maximum, or the lowest valley or minimum, as we like to call it in mathematics, that distance is called what? That's right, that's the amplitude. Okay. By the way, back to your geometry days. When you're talking about distance, what kind of number are we always talking about in distance? If I walk from here to home, I'm going what kind of distance? A positive number. It's the same as if I walk from home to here. It's always a positive distance. Even if I put my car in reverse, I'm still going a positive distance. Okay. How do I represent a number to make sure that it's positive? That's right. I'm going to put it in absolute value bars. So this A here, is going to equal the absolute value of the number A that's there. Okay, and I'll explain that to you in just a second. Okay, what's the time it takes to complete one pattern or measure it? That's the period, right? And our parent function of the sine, it's 2 pi. So one cycle is 2 pi. Hey, only I can say that. Okay, so that's the graph part of it. The algebraic part is y equals a sine of bx. Okay. Now I use theta. I told you I would probably use theta because that's how I was taught. Oh, the amplitude we talked about already. The amplitude is the absolute value of a. The period is 2 pi divided by b, because we don't have the graph anymore to figure it out. Okay. Now we're just given an algebraic equation here, and we're supposed to find the amplitude in the period. Well, since it's not graphed for us, we are going to do it algebraically. And the period formula is 2 pi over b. Okay, being b the coefficient of x or theta, however you decide to write it. Okay, number one. What is the period of each function? So I need the b for each function. What's my b in a? 1a. That's right, it's 8. And period, I take 2 pi divided by b. So 2 pi divided by b, which is 8. Reduce it, I get pi over 4. There's the period for this particular equation. Number 1b. What's my b? That's right, 1/3. So the period is going to equal 2 pi divided by 1/3. And this is where students go, oh shit, there's a fraction and a fraction. I'm going to skip it. Yep. Okay, so we have to figure this out. How do we take a fraction divided by a fraction? Well, we flip the second fraction and we multiply it. And I get 6 pi. Not that hard, folks. You're big people and big people math now. For you it is. All right, what is the amplitude of each sine function? What's my a and 2a? 2. So what's the amplitude? Positive 2. What's the a and b? So the amplitude is 4. Okay, that's why the reason why I like to call what's inside the absolute value symbols little a, because when we go to graph these, and I'll show you in a minute. All right, number 3, find the amplitude and the period. Okay, what's the period? Amplitudes are easy, right? What's the amplitude for number 1? 3a. 2. What's the amplitude for 3b? And what's the amplitude for 3c? Okay. What's the period for 3a? 2 pi over 2. I'm sorry, 4 pi over 2. 2 pi. What's the period for 3b? Well, it's 2 pi divided by b, which is 1/2. And we know how to do that. We flip it and multiply it. So it's going to be 4 pi. My b is 4. Yes, it is. You are right. You are correct. You are correct, Mundo. Pi over 2. So I have 2 pi over b, which is 4, which reduces to pi over 2. And the period for 3c, it's going to be 2 pi divided by 2. Reduce it, I get pi. Questions, comments, concerns? Because you got a quiz on this Friday. Yes. That's in the formula. 2 pi over b. Okay, you ready? We're going to actually have more funner stuff and graph these. Okay, here's the steps for it. Find the period and create a scale for the x-axis. So here's my problem, 2 sine of 1/4 x. I have to find the period for the x-axis scaling. The period, 2 pi over b, which is 1/4. What does this equal? That's right, 8 pi. So to end here at 8 pi, I need 4 points. What's half of 8 pi? What's half of 4 pi? So what's the other one? Okay, finish step 1. Step 2, find the amplitude and create a scale for the y-axis. So I need to find the amplitude, which is the absolute value of A, that's 2. So the amplitude is 2. So I'm going to go 2 up this way, and I'm going to go 2 down this way. Okay, so I did the y-axis. Now, little a, now this is little a in here. If little a is greater than 1, I'm going to follow this series. If little a is less than 1, I'm going to follow this series. Is little a greater or less than 1? Little a, is it greater or less than 1? Greater than. So I'm going to follow this one. Put a point at 0. So at 0, I get a point. Put a point at max for the next one. There's max. For the next one, put a point at 0. For the next one, put a point at the min. And for the next one, back to 0. Now you can easily draw your smooth, I say smooth curve. And there's my sine function for this equation. Easy peasy, right? Now, where students get caught up on these problems is actually scaling the x-axis because they're not always whole numbers. So when you get a fraction for your period and you got to take half of a fraction and then half of that, it's mind-blowing to students. Absolutely mind-blowing. Why? I don't know. I'm not sure yet. We're trying to figure that out after 10 years. Your homework. Look at a couple of these. Or your practice work, whatever you want to call it these days. Your no work. Okay, this is 0 here. This point is, if you can't read it, pi over 2. Here, it's pi. This point, 3 pi over 2. And this point is going to be, that's 3 pi over 2. What's this going to be? 4 pi over 2 or 2 pi. Okay, what they're asking you is what's the value of theta or x, whichever one you use. They're labeling this x-axis as theta axis. What's the y value? Okay, so at pi over 2 radians, my y value is going to be positive 1. At 4 radians, well, here's 2 pi radians. At 4, it does double that, so it's going to be 0. 3 pi radians, negative 1. You get the idea? Okay, number 12. Is this one of your problems? Yes. Let's do number 13. Okay, here's your y, x, and y axis. They want us to find the number of cycles each sine function has in the interval from 0. So from here to 2 pi, and this is pi, so this has to be 2 pi here. The number of cycles. Is this a full sine cycle? No, it's a half a sine cycle. It's going from 0 to 0. If it was going from 0 to 0 to 0, then it would be a full cycle. Okay, so what do we have to find? Find the amplitude. Now, we have a graph, so we're going to have to use our formula, right? Amplitude is going to equal 1/2 the max minus min. If it was an algebraic equation, we would just use the coefficient A, right? So the max is 1, and the min is 0. So half of 1 minus 0 is 1, half of 1 is 1/2. And I told you it was half anyway. And then what else do we have to find? The period. The period, because we have a graph, we're just going to take and count one cycle. So it's 1, 2, 3, 4, 5, 6. So the period is 6. Okay. Questions? 15 through 20. I'll do number 17. Amplitude is 4, and we have to assume that A is greater than 0, they told us. So we know that we're going to put it in our little formula here. Y equals A sine of B theta. We know that the A is 4. So we have Y equals 4 sine. We have to find B. That's can barely read that. So Y equals 4 sine. We have to find B. They told us the period equals 3. No, sorry, 4 pi. Doing the wrong problem. Okay. How do we get the period again when we're dealing with an algebraic? No, that's if we have a graph. If we have an algebraic expression, it's 2 pi over b, right? How are we going to make this 2 pi a 4 pi? Multiply it by 2, so we're dividing it by b has to be 1/2. Okay? B has to be 1/2. So 4 sine 1/2 theta. Or x, whichever one you guys use. That's my equation. Sketch one cycle of the sine function, so we have to graph it. Let's do one of these. 26. Are you ready? Huh? Are you ready? Are you ready? Y equals -4 sine 1/2 theta. Okay. Step 1. Well, I better put my graph on here. Okay, step 1, find the amplitude. Equals the absolute value of this coefficient, 4. Or I think actually this is step 2, but that's okay. So we have 4 and -4, right? Find the period. Equals 2 pi over b, which equals 2 pi over 1/2. Is it 1/2 or 1/4? 1/2. So that equals 4 pi. Okay, so my x scale here is 4 pi. What's half of 4 pi? What's half of 2 pi? 1 pi. And what do you think this one is? Okay, now remember, this is little a here. Okay, that's little a. Is little a greater than 1 or less than 1? Less than 1. It's -4. So we're going to start at 0. We're going to use this bottom one now. We're going to put a point at 0. Next point at min. Next point at 0. Next point at max. And last point at 0. So this sine function, because of that negative, is going the opposite way, or reflected. And there you go. Questions, comments, concerns? You have 20 minutes to do this. If you finish this, which you should, pretty easy, you can work on your multiple choice final review. Questions, comments, concerns? Alrighty then.